Hey everybody, hopefully I can be heard and I can see there's people already watching, which is amazing. Let's see if we can just make sure I've got everything up here. I'm still not used to doing this, so we'll just make sure everything's working. I believe it is. So, thank you, welcome to the stream. It's been an amazing couple of weeks for the channel. First of all, we crossed 1,100 subscribers, which is cool. You know, when we set this channel up, I never thought we'd get past 100, never mind 1,000, and it's continuing to grow. So if you can give us a hand, keep trying to share the channel, keep trying to push it. We've had some interesting things where I've tried to post into groups and things like that, and my posts have been taken down because I guess people don't like free knowledge sharing. So yeah, if we can get that out and get that away, away we go. So I can see we've got some chats coming through. There's a bit of the delay on you guys typing and me seeing it, but I've got here, hi from Thailand. Oh, that's great. Love Thailand. My family's from Singapore, half of them anyway. We'll be back there soon. We love going to Thailand. Indonesia, awesome. Love going to Batam, so that's great. I love it when people from all over the world are here. Yeah, we go back to Singapore in September to see the family, so we should get some snorkeling and things in around Indonesia and Thailand, hopefully. But hey, enough of that, I guess, because nobody really wants to hear about my holidays. Practical sessions. New change to what we're doing. Anybody who hasn't seen the videos up to now that I've been putting out, just a quick recap. So the practicals used to be a pipe like this. This is not one of the current TWI samples. Algeria, oh, awesome. So I've got Africa, I've got Southeast Asia, great. Anyway, these are not the TWI samples, so I'm quite happy to show them. But it used to be like this, is a pipe and one is a plate, okay? Was a bit of a pain getting in and getting around, and really the pipe and the plate exams were exactly the same. And you know, me teaching this for nearly 20 years now, never really saw the reason why we had a plate and a pipe, because a plate is just a pipe wrapped around into a circle. So it's been changed. And what it's been changed to is a key ring that holds 8 segments. So that looks something a lot like this. I've only got 6 segments on my training samples that I make, but we've got 6 segments which are like this, and on them you have a face and a root, okay? And they're lettered A, B, C, D, E, F to whatever sample we've got. And the idea is that they can make multiple examinations from this, okay? So where back in the past there might have been some exam loss of security by people learning, say, what's an exam 1, now you won't be able to know what your exam's going to be, because there will be a mixture of a variation of all of these plates. And if you've got 8 segments, well, how many variations of that can you have? So it's going to change the way the internet works, really, and what people can find online. I would, for at least, you know, for the foreseeable future, don't bother buying exam papers that people have online, because I don't think they're worth it anymore. People are selling them for like $15 and stuff I've seen. When I've read them, because people send them to me. A lot of these exam packages are sold as exams, but they're not. They're just the training questions you get out the books. So don't do that. Let's learn how to see defects, and then no matter what exam package you get, you'll be able to knock it out of the park. That's the hope anyway. It's very different from how it was. The whole way the exam is built is different, and we're going to go through that today. And what we'll also be doing is answering questions, okay? I want to build questions, and I want people to come and see these videos and stick it down in the comments, you know, what their concerns are, what their expectations around the exams are, and I will answer as many as I can. I try to answer every single question as it pops up onto my feed through the YouTube studio, and I will continue to do that. You guys are spending a small fortune on doing these courses. Don't let people sell you additional stuff that you don't need when it's here online for free, okay? But hey, it's your money. You'll do what you want with it, I guess. So 8 samples like this cut down. So what we're going to do today is we're going to look at some, I've got some off of the key ring just to make it easier to see on the camera. You can see I've got a camera here, hopefully looking down, and we're going to run over how this looks. Okay, right. So that's me trying to get through the preamble as quickly as possible so we can just get into what we need to do, right? So next change in the way that the CSWIP course is being given. Oh, well, before we say that, so I taught the first course in the UK for this new system 2 weeks ago. It is so different. It's not funny how different it is. One of the first big differences is now you will get 2 folders, right? You will get, which one is it? You'll get a folder which has all of that normal textbook stuff in it, right? That can be sent to you once you pay for the course. Then, when you arrive at the course, there is a second folder which is called the student workbook. Okay, the student workbook holds all of the PowerPoints, and at the back is where you've got the homework questions, and I've opened it here a bit for the WPSs. We're going to do WPSs in another live stream, but all of that question stuff is at the back. The idea that the Institute have had is to change out the way they give you the information ahead of the course. And the sort of thought process in that is that when you do the course, you will be seeing the questions for the first time, so we can go through it with you. One of the real big problems I have on these courses is trying to correct people's understandings once they have they've already learned something incorrectly, and if they've already done the homework questions before the course, it's quite difficult to fix that. So they're not going to be giving these away up front. You'll get the book, which has got all the text for you to read through, but all the slides and all the questions will come to you on the day of the course, okay? So there's that slight change as well, right? So with that, how do we do a practical? Well, first question, who's worried about this new system? Does this have anybody got the fear of God in them about how to tackle this? And I'll just sort of like talk while you catch up with what I'm saying. I think it's better in some ways. It's more difficult in others. I will not lie. The new system of negative marking is a need because of the way to do the exam. So we'll look at that. And negative marking terrifies me. I will not lie. I've had to do negative marked exams for things like the European Welding Engineer course and things like that. I think I've got my processes and how to deal with them, but I think most of the people who have failed following the change in the course have probably failed because they've guessed an extra question and therefore lost a mark. So we'll look at negative marking as well. But yeah, it'd be great to hear how you guys are sort of viewing this as students or potential students around what you've seen online before and what you haven't. Okay, if I get some comments coming in about that, we'll talk about them as we go. So let's have a quick look at hopefully, right? Yeah, great. So on our down camera here, you can see we've got a sample. The sample, we are only inspecting the front, so the face and the root. We are not looking at the cross-section of the samples, okay? So just the face and the root. For the exam, we need the sample. We need one of our rulers, so I've just got one of the TWI bendy rulers because I've got a drawer full of them. Put this one over here. And we need our welding gauge, okay? So if you haven't used one of these cam gauges before, we do have a video on the channel about it. It's actually one of the most viewed videos on the channel, which has surprised me, but yeah. So we've got our gauge. So we've got what I refer to as the elephant's nose, because that's what it looks like to me, and the stabby bit for fillets. Now we're going to ignore this bit and just go with the weld gauge here. Now the only thing we're going to use this weld gauge for is for the cap and root penetration heights. Okay, so it's a very small part of the exam in general. So we'll put that to one side. But here's our sample here and what we're looking at. Okay, so we've got that. Now I should hopefully be able to say, there you go. So here we then have our acceptance criteria. As you can see, the acceptance criteria is split into 3 groups. Now, if you've used ISO 5817 in the past, it works very much like that. It's not exactly the same main acceptance criteria, but it's structured in a similar way. We can see down the left-hand side, we've got our defect types. So here we've got excess weld metal, underfill, slag, undercut, and hopefully I can go down here. Yeah, undercut, stop-starts, lack of fusion. You've got arc strikes, mechanical damage, penetration, height, lack of penetration, lack of root fusion, burn-throughs, and concavity. Okay. These are the only defects that we care about within the exam, okay? If you have a defect that is not on your sample here, which is not within this acceptance criteria, ignore it, okay? They only want you to look at the acceptance criteria versus this. It's like the standard being silent in what we're doing, okay? So we've got that point there. Right. Next, again, hopefully I can get this to pop up nicely. There we go. Here is our questions and how you will deal with them during your training. Sorry, I've just lost my screen so I can see the chat. Here we go. Along the top here, we've got question 1, 2, and 3. So our question 1 is, what defects do you have? Now, that's with regards to this one sample. So you'll have 8 of these. But on sample 1 or sample A or whatever letter you have, what defects do you have? And you can see along the top of that question paper, it's got excess weld metal, underfill, and all the defect types. And underneath that, I've got defects A, B, C, D, E, etc. Those A, B, C, D, you can see on our acceptance criteria, tie into our defect names. So excess weld metal is A, underfill is B. I say that, and we've got to remember, no, I wouldn't memorize it because you'll have that acceptance criteria in front of you, but in an exam, what's in blue on the screen there, so the excess weld underfill along the top, isn't there. You just get A, B, C, D, E. I've added them to my form so we can see it, just as we start pulling things together, right? So, how do we do this? What do we do? Now, I'm going to work through my methodology of doing this. You don't have to do this in the same way, but I think it'll make sure you don't miss anything in a way, and you won't get yourself confused. Right. So, what you do is pick up your sample, and we're going to come to the first defect, and I'm going to say, right, my first defect on my list is excess weld metal. Do I have excess weld metal? So the answer is yes, right? It just means, is there anything that's protruding above the surface of the plate? So if I come back to my other screen, what I'm going to do, I'm going to come to there, and I'm just going to put a big giant X in the box and say, yes, I have excess weld metal, okay? I then go, well, have I got underfill? Right, let's have a look. And then I can say, well, do I have any underfill? So let's look at it. So generally with these samples, what we can see here is we've got some underfill on the end of our bit. So here we know we've got underfill. It doesn't matter how big this is at the minute, but we can see that that groove isn't filled up completely. So again, I'm going to put an X in that box and go, I've got underfill. Next question, do I have slag? I'm looking at mine, I'll try and bring this up to the camera a bit and make sure. Shiny surface struggles to pick up on the camera, but I don't think I have any slag. Okay, so I can miss that one out there. Do I have undercut? Yes, I definitely have undercut. Now, with this defect, you won't be able to measure it with this gauge, okay? And the reason you won't is because the point on the top of this gauge is too big to go into the undercut. So the best thing I find to do is just to take my nail and try and run it across the toe of the weld out from both sides. And if I get it, hopefully you can hear this click. That's my nail catching the undercut at the toes. So I know I've got undercut there. I can also see that it's undercut and not lacquer sidewall fusion because of its shape. It's rounded. It's not a straight line. Okay. So I'm going to say, right, I have some undercut. Do I have any stop-starts? So this is a new defect to the exam. This wasn't in the old version. And what we need to do here is decide, okay, I have a start, but in my section, do we have a section where we've welded, stopped, and restarted again? I would say no, so I'm going to ignore that. Have we got any lacquer sidewall fusion? The answer is yes, because we can see it, again, catching this in the light there. See that very, very straight line on my sample. So I've got lacquer sidewall fusion. Do I have any arc strikes? So I'm going to look at it and go, well, what have I got here? On my sample, actually, I can see clearly that this is mechanical damage. These are like chipping marks and things like that, so I'm going to ignore this. This here doesn't have any melting around the plate on the outside of this thing that's sticking up. So I'm going to say that's spatter. I'm going to say it's not an arc strike. So I'm going to ignore that. Mechanical damage, yes, we've got mechanical damage, because there that is. There we go to penetration, so we can flip this over. Have I got penetration? Yeah, I have got penetration coming through. It's very small, but it's there. So, have I got any lack of root penetration? Again, I can look at my sample. So, lack of root pen. I can't remember what it is. I'm in the middle of my exam. I go, I know lack of root fusion and lack of penetration are very similar, right? But which one's which? How do I know? Well, one of the things we can do, right, and I would say it, is look at our remarks section within our acceptance criteria, and you can see there's a little bit of explanation about what each defect is. So if I then go down to lack of penetration here, lack of root penetration is J. So yeah, that's where we're at. We're in J. The absence of weld metal in the root area, 2 straight faces shown. So now I can look at this defect here and say, have I got 2 straight edges either side of the root where I haven't made penetration, basically? And I'm going to say, yes, I can. Now, I did have a torch somewhere. Oh, here it is. This might not work because of the camera, but one of the good ways to do this is to take one of the torches you get while you're on the course, or have your own torch. Remember, you can't bring your phone into the exam, so you're going to need a normal torch. If I'm struggling to see a straight edge, what I could do is put my torch on and just try and cast a shadow and see if I've got the straight edges. Now, again, on YouTube it's hard because the video quality isn't as high as what we would like because of the compression rate, but I can see from mine that I've got 2 straight edges either side of that weld. That might be a good view there. So I'm going to say yes, I have an area of lack of penetration. Hopefully everybody's with me at this point. If you've got any questions, please jump in at any time. Okay. So we look at that. Again, I'll just bring up what's my next question? Do we have any lack of root fusion? I think we're okay. We've got no lack of root fusion. And again, by looking at our acceptance criteria, we can see that that's 1 straight line. Now I've got this bit here, which is definitely lack of pen. So I'm going to just say that's fine. And then I've got burn through. I've got no burn throughs. So that's all right. That'll be a big hole in the root of the weld, where it looks like there's been too much heat and the weld has just cropped out and fallen through. I haven't got that, so that's fine. Root concavity, I've got no root concavity. My root is flat, but it's through. You know, it's pretty much perfect. You know, if you didn't want any penetration coming through, but you wanted to catch both sides, here and here, that's quite good. It's just not here. Okay. So now I've done my review. That's my very quick question 1. What defects do you have at both the root, at the face and the root? Okay. As you can see, we've lost a step in this new exam where we now don't need to draw the locations and do the old weld map. So that's a great thing. Yeah. So we've got that. Now, if I then look back at my gauge, okay, I can decide to start measuring defects, which is what is in question 2. So question 2 says, which imperfections are rejectable in accordance with category group A? So I'm going to look at group A and say, right, I've got excess weld metal. how much excess weld metal am I allowed to have? Okay, so if I come back, I can go back to my acceptance criteria. Okay, excess weld metal. Excess weld metal is anything above the plate, and it needs to be a maximum of 2 millimeters. So, take my gauge. First thing we do before we ever look at taking a measurement here is to check that we've zeroed the measurement. Okay, a lot of people fail this test because they haven't checked to make sure this is zero. Way to do that: put it on a flat surface, push that right down so we can check, and now we can check the measurement we get. Okay, mine isn't reading zero. I've just picked this out the drawer, so now I need to change it. I do have a screwdriver around here somewhere. So we need to re-zero this back to a decent amount. Hello from the UK. Great, at least there's one. So we're reading here, I'm about -1 millimeters. So what I do, flip this over. I've got 2 screws. I just need to back these screws off. Here and here. Yeah, try and use a screwdriver live on stream. It never goes right, does it? Sorry, I'll lose my voice already. Let's then move this so our zero lines up. So that's got that nailed there. Trying to hold it so it doesn't move again. Let's just tighten this up here and here. Great. So now, if I recheck that, right, it now reads 0, which is what we want. So now I can come back to my sample, and I need to take the excess weld metal size from this. This is where we come to another challenge, okay? In order to get a good reading from these cam gauges, we need this face here and this one to lie flat on the workpiece here and here. Okay. If you don't, what you find, it'll rock about. Now you can see the size of these two together. Can't get them both on the screen now. If I try to put everything on one side and take a measurement, the back side of this gauge is off of my sample. That is going to happen in your exams, okay? So we've got to try and be as careful as we can when we're taking these measurements. So what we're going to do is put one face under here, come across and take a measurement there, okay? And then what I would do is I would drag the gauge around just so I know I've got the highest point of anywhere on it, making sure that this bit next to my thumb is as level as we can keep it with the plate. If I start letting it move up or down like this, I'm going to get a different measurement. Okay, so grab that, take that like that. All right, so now I can look at that and go, right, I have a measurement of 3 millimeters. Right. So when we get to question 2, it's asking us which defects that we found are rejectable in accordance with we're saying here I'm allowed a maximum of 2 millimeters. So I would now reject my excess weld now. Then I can come along and go underfill. So underfill is not permitted, so I'm going to reject that one as well, because we know we've got it. I've got undercut, so what's my acceptance for undercut? Here we've got undercut D. At A, no sharp indications. The length of any undercut shall not exceed 5 millimeters. And it should not be more than 1 millimeter deep. Now, this is the way I see this, right? This isn't an official TWI thing or anything like that. I just want to make that abundantly clear here. The likelihood of having smooth undercut is actually quite low. If you can get your nail in it and click it, like I said before, that's sharp, right? At this point, I wouldn't bother measuring it because I've already got a rejectable output. So because my acceptance criteria is no sharp indications and I have sharp, it doesn't matter how long it is. So I can go back to my thing and say, well, I'm going to reject the undercut without really thinking. Okay, I've just saved myself a load of time and a load of hassle by doing that. Lack of sidewall fusion. Again, we come back to our acceptance criteria and we come down. So lack of sidewall fusion here. You can see that is in with laps and cold laps. So just keep an eye on that. So it's Cat A, it's not acceptable. So I'll come back to here and go reject that as well. Mechanical damage, back to my acceptance criteria, mechanical damage. So there's no straight tack welds, well I haven't got that. Parent metal must be blended smoothly and a max depth of 5mm only in one location. So we know we've got this here. I'm going to class that as one location because they're together. Are they more than 1/2 mil deep? That's really hard to see because they're quite small indents. So I'm looking at my comments here, saying excluding any hard stamping or pot marks. I don't think these are pot marks. I think this is like a hammer mark or something like that. So I'm going to class that as a defect. I'm then going to say, right, it doesn't look smoothly blended. So I'm going to reject mine based on, again, on the blending. Right, I get to my penetration height. What's my penetration acceptance criteria? So I'm allowed up to 2 mil in height on my penetration. So quickly give that a measurement. Well, I don't have to measure it really here because I know this is definitely under 2 mil. So I'm going to accept that, which means I don't put an X in the box. And then my next one is lack of penetration. So the last one I have, I go lack of pen. There's lack of pen. I'm allowed a maximum of 5mm. So I need to look at this and decide if it's 5mm or not. I drop my ruler. So I want to put that on there. Measure that. Now I'm try and get it into focus anyway. 10mm. So that would be a reject for me going into that section as well. So now I've just done that for Cat A. You can see that as we would expect, Category A is very tight. It's very stringent and it'll probably reject a lot of things. If you look at ISO 5817, that fits exactly. Category B, which is the most stringent one in 5817, pretty much rejects everything. So we've got that now. But now, oh, you know what? I've got a typo on my sheet. That should say Cat C. Right. So I'll change that quickly. Now we've got to go through these and check Category C. So this is the way that the examination is making sure that you can bounce between acceptance criterias and not just use one but use two basically for different things. So we can come back to the top. So at Category C, we're allowed a maximum of 5mm, right? So where I was measuring, oh, what was I measuring? I can't remember now. Let's give that 3mm. I know that's acceptable. So again, on here, that's now doesn't have an X in it because I'm accepting it. Underfill, I'm allowed up to 5mm in length. So how much underfill do I have there? I think I have about 3 mil in length, so I'm going to accept that. My undercut, éclairci, the length and of the undercut. Let's just make sure I bring that into frame nicely. The length of any undercut shall be less than 25 millimeters, continuous or intermittent. Right. So have I got more or less than 25 mil on there? Well, without having to measure that, I can just say that's less than 25 mil of undercut. So I'm going to accept that one as well. Lacquer sidewall fusion. Again, come back to here. Lacquer sidewall. Surface break and lacquer sidewall fusion and lack of interrun must not exceed 15 millimeters. So again, I'm going to come and say, well, that's 5 mil. I've maybe got a tiny bit there, 5 mil. Now I maybe got like 10 mil on this sample. So again, that's acceptable. So I'm not going to put a cross in it. Mechanical damage. Come down to mechanical damage. 1 straight arc is permitted. The parent material must be blended smoothly. Well, so I can't, you know, it's not smooth. We made that decision before. So my mechanical damage is going to get an X in it. And then my lack of pen for the last one is going to go, okay, lack of root penetration, 15 mil. So I think I measured 10 mil before, didn't I? Okay, so 10 mil. So I'm not going to put a cross in that. So what you can see there now is I've got, what defects do I have in question 1? So I've got a long list of defects. Question 2, I'll probably have less crosses because there's probably going to be at least one thing that's acceptable. I don't want to guarantee that because I can't. You know, it depends which exam you get, which questions you get, and the likes. But you can see there's less crosses. And then question 3, for anything against Group C, we can see there's even less crosses. So that's the pattern we should be getting. Lots of crosses, some less, and then not very many. And that's a good check, I think, for your exams or your training, is that if you've got more crosses in C than in A, you've got a problem, you know, and you need to look at it. And you can see by being as accurate as I can be about which defects I have in, then I don't have to check everyone against the acceptance criteria. So if I don't have any slag inclusion, I don't need to look for it anymore. I can just ignore that thing. And by going through the acceptance criteria line by line to do question 1, we know we're looking for everything we need to be looking for. Example, these 3 dots, probably everybody saw and wondered why I wasn't looking at them. Well, I'm going to say that is not an arc strike. It's just, it's the wrong shape. It's sitting on the surface. It might have been some paint or something like that, you know, on the surface when they took the mold here. It doesn't matter because I know it's not an arc strike, so I'm not counting it. Arc strikes are unlikely on the route unless we're doing some bridging dogs or something like that. But it's not in my acceptance criteria, so I can just ignore it, you know. Any hard stamping like I've got here on this end, my acceptance criteria tells me to ignore it, so I can forget about that. And we can move through quite quickly. Okay. Now, some other tips on this. You can see that you've got excess weld, metal, and penetration. That is, you're always going to have that to some level. So you should always have a cross in A and I. Okay, just always have a cross in them on question 1. Everything else, well, it depends. Not all samples are going to have lots of defects in them. For instance, I'm going to show you this one. This one's fairly clean. You know, there just isn't a lot of defects, but there is still excess weld metal, so I'll still have a cross on that. And on the back, you know, I can potentially see some defects here. I've got, you know, a lack of penetration there. I've got stop-start. This bit, again, this bit here is a stop-start. So you might not have a lot of defects when looking at two samples side by side, but you take each segment intermittently, okay? You do one segment and then you do your questions for the next one. So you'll have this thing above, this A to M, question 1, 2, and 3, 8 times, okay? Make sure you're looking at the right sample as well. Right. Hope that's clear for everybody. The next thing we have to deal with in these exams is negative marking, okay? How does negative marking work in these exams? Well, what you've got is the exam is just asking you to put a cross in which defects you have. So let's say we run it where there's no negative marking. There would be nothing stopping you putting a cross in every box and getting all the marks, right? Which, of course, goes against the output of that exam, okay? It wouldn't prove anything. So what we have to do is negatively mark. I say we, you know, I'm not TWI, okay? I'm a dirty contractor. I work and I teach for them now, but you know, it's not my decision, okay? But what the exams have to do, is maybe a better way of saying it, is punish you for putting crosses where they shouldn't be in order to make sure people just don't flood the exam with crosses. So that means right now for this exam we're looking at here, if I get all of them right, I would have 4, 6, 8, 10, 12, 14 marks, okay? Now, if I go and put a cross where I shouldn't have one, so let's say that this one here is incorrect, so I'll just make that a red just so we can know that. What's going to happen is I'm going to get 14 marks minus 1. So now I only get 13 marks. If I then put another cross in it, I'm going to get 14 minus 2. So now I get 12 marks. And so on, right? Now, that's if we're looking at this sample here, okay? But if I'm looking at this one, right, let's just clear all of this. What I'm really got on this is maybe some excess weld metal. I've got no underfill, I've got no undercut, I've got no mechanical damage in any way. Might have a tiny little arc strike there, so I'm going to put an arc strike in. I've got my penetration height and a lack of root pen, okay, so I'm looking at that, right? So I've got 4 things there, right? If I then put X's, of course, in here, 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 and here, so these are now old X's. What I would have is I would have 4 marks for right, but then I would have 4 marks wrong. So now I have 0 marks for that part of for question 1. So how do we deal with that? How do we make sure that we're as safe as we can be during the exam? And that's, well, first off, it's to know the difference between defects. That's an easy thing to say. The way I deal with this is if I'm unsure, I don't put a mark, right? So let's say I was looking at this and I was unsure if I had a stop-start or not. I know I've definitely got these 4, but this one, I don't know. Do I put the X in or don't I? If I don't put the X, if I do put the X, I get 3 marks because I get my 4 minus my 1. But if I don't put it, I get my 4. and there might have been 5 marks, but I get 4, but I'm not losing a mark. I think it's worse to lose marks than not gain them, because it's almost a double effect in hitting us where we are. Okay, so just try not to over inspect the samples. You saw how fast I did that one. That's where you have to be. You need to be relatively confident in how we're assessing these. If you're holding it up to your face and you're going, oh, is that a defect there? I'm not sure. It's probably not. These defects will be quite big. I mean, yes, the quality of YouTube video capture is a bit low, but hopefully you can see there is places we're going to look on this sample. We shouldn't be missing them, So that should be a bit easier. Yeah. So that's what we want. So how are we feeling about that? Are people happy with that as an explanation? You are going to do lots of these during your official course. Okay, you're going to probably do potentially 3 sets of 6 or 8, depends on how many is on the training key ring. So you're looking at doing what, if they're 8, you're doing 24 samples before you get to your exam at the end of the week. Hopefully that keeps that relatively, you don't get nervous about it. That's the worst thing in these exams is getting nervous about it. Okay. And I'm running out of things to say about the exam. Just take your time, look at it, make your decisions, put the crosses where you need to put the crosses, and you go on that now. Okay, so we've got somebody saying, hi, I'm about to take my test in a week. Oh, good luck. Can you please confirm if the negative marking for the practical test is only for the entire exam? Right, so the negative marking applies to all 3 parts of the exam. So you can see how it works with the practical. That's easy. In the multiple choice, there is sections which have more than one answer. So there's some straightforward, is it A, B, C or D questions. There's some drag and drops where you have to move the correct answers into one box and the incorrect answers into the other. If you mix them up, there's negative marks on that. And there is some questions where you fill in the missing word, and there's negative marking on that also. Okay, so there is there is negative marking on everything. Okay, again, you kind of push for it, and then we should be all right. But it's caught people out. Negative marking is difficult, Next one. Do you have a copy of module of new system for us? Sorry, I don't know what you mean, a copy of the modules. If you want to see a breakdown of the overall course, there is I've done a couple of videos on the channel. If you have a look, I think they're still titled New CSWIP. So there's one on the overview. Hopefully that answers your question. I'm trying to keep away from issuing paperwork that the Institute might see as me overstepping the bounds, which is why I've come up with new samples and things, so I'm not using theirs. But if there's something specific the group or the community wants to see, if you could give us some sort of explanation in a bit of detail, I'll see what I can produce, And then we've got what we've got next from the UK. Root concavity. Root concavity is fairly straightforward. Hopefully, I'm just going to swap back to this camera, not the starting screen. So, root concavity. Take your root and we can see there's lack of penetration here, right? Root concavity would be if you could see the weld metal, but when you feel it, it goes down like it's concaved. So best way is you go, well, I've got no straight edges, but I can feel the weld metal going down into the plate, then it's concavity. Yeah, cool. Right. Why is negative marking? Do they really want people to fail? Do you have recent example of multiple choice questions? Right. I honestly do not believe they want people to fail. There is no driver to have people do resets. Okay, let's put our very cynical hat on and say, does the Welding Institute want people to fail their exams? It's much better, and they make more money, I think, if you pass your exam and then you come back to say do your 3.2 or something like that. There's money in that. Running reset exams does not pay. It's an expensive thing to do, to pay for a lecturer to do a day's refresher training and then to sit in an exam room for at least half a day. They don't want that to happen. But there is a heavy driver from industry to want to see more strict exams to make sure people who enter the workplace are competent. It's very difficult to do in an exam, and I have personal gripes against the whole way that we assess for competence, just in general. You know, we put a lot of thought into physical qualifications that don't prove competence in any way. So yeah, I don't think they want to do that, but they need to make sure. I think the fundamental driver is exam security. If you've got one exam, or say 5 exams, it doesn't take long for everybody to sit the exam and then learn what the exam is and then answers to get out. We've seen that through multiple exam structures. You know, we've had things over in Southeast Asia with PCN in the past few years. We've had exam security all over the shop, okay? And that needs to get better. I employ people, so Carbon Arc, we do weld inspection, we do welding engineering for people, and making sure there is valid qualifications is really important. But all that said, yes, I believe the exam failure rate is going to go up some level. I just think it is. I haven't seen the exam results for the courses that I've taught so far. You know, we very rarely find out. So we'll see. I'll probably wait maybe a couple of months, and then I'll look to do a recap video on this statement, and I'll see if I've strung myself up or not. But I think it's going to be difficult. Yeah, I'm going to go round in circles with what I'm saying, of course. But yeah, we'll go there. When you're measuring underfill and lacquer sidewall fusion, do we measure with the reference to the base material? No, the base material thickness doesn't matter. This thickness here on the sample is changeable across samples, so don't worry about that. It's just, is it there or isn't it, in the length of those defects. How do you recognize slag inclusions? Slag inclusions are really difficult on these. I'm just looking to see if I've got slag inclusions on any of these samples in front of me, and I bet I don't. I don't. Let's just see if they're on the other plate keyring I've got made up. I don't have any slag. Porosity is dead easy to see, by the way, just because this one's got porosity on. There you can see porosity in this section here, wherever that is there. It's really quite obvious. But slag inclusions are difficult because there's no colour change. Within a normal sample, you would get the black of the slag on the metal. I want to say the silver of the carbon steel, but it's not silver. You're looking for something that's a bit bitty and a bit like all over, not smooth. It's probably sitting on the surf, like in the toes of the weld or in interrun fusion. And what you'll do is you'll see the weld metal go around it. I'll try and do a better video of that. It's difficult. What we got next? Right, side conclusions. Oh, thank you for the tips, James. You're a superstar. Oh, thanks, Mozambique. Oh, wow. Okay, thank you. It's always terrifying when you put yourself on YouTube and start talking to people. So I appreciate the kind comments. That's great. Hi, I'm from South Korea. Hey, South Korea. We watch a lot of South Korean TV in this house. Like I say, my wife's Singaporean. But we just finished watching Physical 100 with a load of superstar South Korean sports people. That's an impressive show. I'd love to go to South Korea at some point, I think. I want to know if you think it's possible to get 100% in either both sections of the exams. Have you marked it? Right. It is possible to get 100%. Absolutely it is. I think naturally in the 80% multiple choice, yes it is. I know only a very few people who've actually done that. I won't lie. My senior 10-year renewal, I did just before COVID. So what this would be February 2020, 2021, something like that. Yeah, lose the dates. I didn't get 100%. I was close, but I didn't get it. I think I rushed the exam as well. I passed, and that's all I care about. It doesn't matter if you get 100% or 70%. A pass is a pass. So just go with that, you know. I think on the practical side, you're likely not to get 100% because you've got to, there's that qualitative measurement, which means that everybody disagrees about certain defects. Okay. Can you explain lack of interrun fusion? How do you recognize it? Okay, lack of interrun. I'm just going to jump back to that other screen. So here we go. So when I've got two runs on a plate like this, interrun is where we have a non-smooth transition between one side and the other. Again, I am still making my own training samples for this, so I don't have every defect captured yet. Well, that's close. So here, where we've got the runs between it, you see that? Now that's actually undercut from the second run into there, but that's in the same position as interrun fusion would appear. And what we're looking for is a non-smooth transition between the two runs, basically. Okay. Yeah. Okay. Well, it's been an hour. I have to go. We are getting ready, so next week we have a very busy week. Well, this weekend we're racing. I tell you what, if you get a chance and you want to have something pop up on your LinkedIn feed that isn't just about welding, please, it would be great if you could come and have a look at our motorsport page. I'm trying to find it. I've got it up somewhere here. Here it is here. Carbon Arc Motorsport. So this is our race team we've started. We're going to use it as a way of teaching engineering to lots of people. We've currently got 25 followers. So, you know, if you want to come and see it, we do some racing. We're trying to teach everybody how to do fabrication, engine maintenance, and all that type of thing. Come and give this a like and a support, and that will be much appreciated. So we're racing this weekend, and then next week we've got a lot of teaching. I will be teaching 9001 next week, which is always fairly in depth. So I'm going to go and get ready for that. Probably during the week I might do some stuff from a hotel room, and talk about things as I start to understand where we go from there. Okay. One last question is, can we have this clip to watch it again and again? As soon as I click end stream, it should upload to YouTube as a video you can watch. So you should be able to see it as much as you want until you get sick of my voice. That is, of course. The Philippines as well. Great. So we've got Indonesia, the Philippines, Mozambique, UK. You know, great. Get the word out. Let's see how many people from around the world we can get into one place. Right. With that, and guys, I will see you later. Good luck with your studies. Keep an eye out for our next video. What I'm going to do for the next one is the welding procedure questions and how to kind of go through them and understand it. I think that's probably going to be the highest failure rate, to be honest, because they're new questions. You know, they're not things that exist on the internet at the minute. So, okay. Thank you, guys, and I will see you all later.